humans, I'm Mr. King. Hello everyone. So today we are going to do Major Paper 2021, Paper 61. Alright, okay, let's go. See, first one, labelings of apparatus. So first, you see A. What is A? You see, A is pointing towards the bowl-like structures. You see, the bowl-like structures is what we call mortar. Okay, remember you see, do not put pestle and mortar. Why? Because it is only pointing to the bowl, okay, not pestle. Alright, okay, then B, tripod stand. And C is what we call filter funnel. That's it. Yeah, then given with this, chromatography. So complete the diagrams to show, okay, the spot of the color solution should be placed on the paper and also the levels of the solvent. Okay, so remember, okay, the substance, it has to be on the baseline. Okay, on the baseline. Okay, and then the solvent level, it has to be below the baseline, but you have to make sure that, okay, parts of the paper, okay, is immersed in the solvent. Alright, okay, then next, okay, why pencil is used to draw the baseline but not the pen? Okay, this is because, okay, pencil, it is insoluble in the solvent. Alright, okay, next one. So given with these two chromatograms, you see, C1 determines the numbers of colored substance in the solution obtained from the berries. See, based on the diagrams given, you see, it produces two spots. So from here we know it contains two colored substances. Alright, okay, then use the data in the table and the result, okay, to give us possible identities for one indicators in the berries. So see, so we have to refer back to the result. You see, in acid and in sodium hydroxide. So we should see, in acid it could be red and blue. So you see, acid, yes, red, no yellow, blue, yes, and there's no purple. Okay, you see, in alkaline, it can be blue or green in color. See, in alkaline, yes, blue, no, there's no red, green, yes. So you see, so which indicators, okay, shows the colors in both acid and alkaline? Okay, the same as the one that's given in the chromatograms. So answer is anthocyanin. Okay, that's it. So this is how you look for the answer. Alright, okay, next one. So you see, given with this experiment, okay, about the temperature decrease when sodium hydrogen carbonate reacts with acid. Okay, see, tabulations of data. So you see, how do you say, is it 20, 21, 22? So 22, 22, and the next one, you see, it is somewhere in the middle of 22 and 23. So we know it has to be 22.5. And wait, remember, when it comes into the tabulations of data, remember, okay, you have to make sure that all the values, okay, they have the same decimal places. You see, this one, it has to be 22.5. So 100% will be one decimal place. So the rest you have to make sure they also have one decimal place. Remember, okay, consistency is needed. Alright, okay, so next one, 23.0, 23.0. Okay, then temperatures after 1 minute. Okay, so this one, 19.5, 17, 14.5, 13.5, 14, 14. Temperature decrease, so initial minus final. So 22 minus 19.5, we will get 2.5. 5.0, 7.5, 9.0, 9.0, 9.0. That's it. Okay, then next one. I see. Plot the result and you're asked to draw two best fit straight line. Okay, and the first straight line should be for the first 3 points and must pass through the origin, okay, OO. Okay, and then the second straight line should be for the last 3 points and must be horizontal. You see, extend your straight lines so that they meet each other. So which eventually isn't it? Okay, your graph should look something like this. See, you have to extend, okay, to show that both the line that cross each other, okay, and causes this intersection. All right. Okay, then from your graph, you see, determine the temperature decrease and the mass of sodium hydrogen carbonate, okay, where two straight lines meet. Okay, includes appropriate unit. So you see, let's look at result. You see, see both the line, okay, they cross over here. So one more thing, okay, you have to show how you get the readings, okay, so you have to show it by dotted line. Okay, and then so from here we know that, okay, temperature decrease, you see, we know this is 9, and then for this one it is 3.6. Okay, so 9 degrees Celsius and 3.6 grams. Okay, please be reminded to include the unit. Alright, okay, then why the temperature decrease become constant, okay, for high mass of sodium hydrogen carbonate? Why? Okay, see, when the temperature become constant means there is no more reaction. So in what condition there's no more reaction? Okay, so from here you know that, okay, it has to be all the acid they are fully reacted or all the acid they are finished used up. Okay, so that's the reason why, okay, temperature remain constant, because there's no more reaction. Okay, next one. See, the investigation was repeated with dilute hydrochloric acid, see, of half the concentration but using the same volume. So sketched on the grid, the graph you would expect to obtain. You see, when the concentration decreased by half, what happens to the temperature decrease? The temperature decrease will also get decreased by half. You see, 9 divided by 2, you get 4.5. So we know that this is fine. So 4.5 is supposed to be somewhere around here. Okay, so the graph says, see, initial pattern it is the same. Okay, it will increase. Okay, but when it reach 4.5, it stop and intersect. Okay, sorry. Okay, so eventually, okay, it will look something like this. Okay, and then label your line D. Okay, so this is how it looks like. Okay, the temperature decrease, okay, it will get decreased by half. Alright, okay, then next one. Okay, what are the two changes, yeah, that can be made to improve the accuracy of the result? So now let's check the procedure of this experiment. See, very first one. Okay, remember, see, when it comes into this improvement, isn't it? Okay, the very first thing they will always check is, okay, what is the tool that they use to measure the volumes of liquid? See, in this case, they're using measuring cylinder. Okay, see, we know that measuring cylinder is not a suitable tool or accurate tool to be used to measure the volumes of liquid. Okay, remember, a better tool to be used is pipette. Okay, another one, you see, this experiment, okay, is about changes of temperature. Alright, so see, everything, you see, they carry out using conical flask, okay, which is not a good heat insulator. So in this case, we need a good heat insulator to prevent heat loss. So from here you know that, okay, so the two improvement, okay, the very first one, okay, we have to use pipette. Okay, why? Because it is more accurate than measuring cylinder. Yeah, another changes, okay, we use, okay, what is the examples of insulator container? Okay, the most common one, okay, we use polystyrene cup. Okay, why? Because it helps to insulate heat and prevent heat loss. That's it. All right. Okay, and then next one. See, this is about the anion cation test. You see, first, the solid, it was heated. See, when it was heated, okay, steam given off and condensation takes place. So based on this test, we can conclude that this solid is hydrated. Okay, it contains water. Okay, then see, tested with acid and then followed by silver solution. Remember, you see, every single time when you see silver solution, 100% they are testing for halide ions. But observation, no visible change, which means there is no halide ions. Okay, no group 7 ions. Next one, test 3, test with barium. Okay, whenever you see the word barium, 100% they are testing for sulfate. You see, produces white precipitate. So from here, we know that there is sulfate ions. Yeah, then acid aqueous ammonia was added. It produces white precipitate. See, remember, ammonia in excess, white precipitate remains insoluble. Okay, it means that it's presence of aluminium ions. Alright. Okay, then followed by the addition of sodium hydroxide solution. You see, we know that aluminium, okay, the white precipitate will dissolve in excess. You see, white precipitate dissolve in excess of sodium hydroxide. And then the products from test 5, see, it was warm, and then the gas given off, it is tested with damp red litmus paper and it turns blue in color. So from we know that an alkaline gas is produced. See, it is tested. See, it is added with sodium hydroxide. See, products from test 5 what? See, it is added with sodium hydroxide, and then it is warm. See, sodium hydroxide and warm. So from here, know that it is testing for the presence of ammonium ions. You see, it produces ammonia gas. Okay, so this is how we look for the ions. Okay, so what is the conclusion that can be made from test 1? See, as mentioned here, hydrated. Yeah, we know that this is a hydrated compound. Conclusion that can be made from the observation test 2. See, no halide ions. So there is no halide ions. Pretty easy, isn't it? Okay, identify the 3 ions in solid E. So answer is sulfate, aluminium, and ammonium. That's it. Okay, sulfate ions, aluminium ions, and ammonium ions. That's it. See, easy 3 marks. Okay. So next one, given with sodium hydroxide, means that it contains sodium and hydroxide. So flame test, you see, flame test is carried out and there is sodium. So yellow flame is produced. So the remaining solution F, blah, 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 blah. See the first portions. Okay, is followed by a few drops of universal indicator. So what is the observation? You see, sodium hydroxide, it is alkaline. So if it is alkaline, what is the color of the universal indicator? Okay, it appears blue in color or purple in color. Okay, both acceptable. Okay, blue or purple. Okay, then second portion is added with, see, it is added with copper 2 sulfate. So what is the observation? See, it produces copper 2 hydroxide. Same thing, see. How do we test for the presence of cations again? Remember, we can either test with sodium hydroxide or aqueous ammonia. See, in this case, you see, it's basically it's like the opposite. Okay, so you see, sodium hydroxide and copper 2, so it produces copper 2 hydroxide. So observation, blue precipitate is formed. All right. Okay, next one. Planning experiment. See, hydrochloric acid reacts with calcium carbonate to make carbon dioxide gas. The apparatus shown in the diagrams can be used to follow the progress of the reaction. The carbon dioxide gas leaves the flask, causing the mass shown on the balance to decrease. So plans an investigation using the apparatus in diagrams to show how the temperature of the acid affects the rate of reaction. Okay, your plan should include how your result will show how the temperatures of the acid affects the rate of reaction. So you see, based on the diagrams given here, this is an example of mass loss method. So which means we can check for the rate of reaction by using this mass loss method as well. Remember, you see, when it comes into planning experiment, the very first thing you have to make sure that you always mention or include all the variables, okay, like constant variables, manipulator variables, and responding variables. The next one, you have to name all the apparatus used. Okay, and then third, okay, you have to give a general conclusion. So you see, the very first step here, so what's the constant? Okay, we have to make sure that we are using the same concentration volumes of acid and same amounts of calcium carbonate. Okay, so you can say, okay, like example, okay, prepared 50 cm cubes of dilute hydrochloric acid using what? Okay, remember, always name the apparatus used using pipette. Okay, and then next, okay, prepare, so calcium carbonate, okay, constant variable, okay, like example 10 grams of calcium carbonate using measuring balance. Okay, so you see, mass law method, so you see, so this is the initial mass, 10 grams of calcium carbonate. Okay, so you see, so after that, okay, we have to add both together, okay, and then for the reactions to be taken place. Okay, add both into a conical flask. Okay, and measure the initial mass. The mass also includes the mass of the conical flask. Okay, so first you measure the initial mass and then start the stopwatch. Record the mass, okay, like example, okay, after 60 seconds. Example, okay, any reasonable time frame you do. So record the mass after 60 seconds, and then we have to calculate, isn't it? Okay, calculate the mass loss by using initial mass minus final mass. And then, now see, now we carry experiment okay, under one temperature. So next you have to repeat the experiment, and you can say at higher temperature or at lower temperature. Yeah, different temperature, okay, because now we are testing for the effects of temperature on the rate of reaction. Yeah, and then lastly, you have to give a general conclusion. Okay, so you see, what is the conclusion over here? The one with the highest mass loss has the greatest rate of reaction. Okay, so the one with largest mass loss is fastest. Yeah. That's it. So this is how it works for this experiment. Alright. So that's all for this paper. Hopes it helps. Alright, thanks. Remember to like the video and subscribe to the channel. See you again. Bye.